Let's take a little bit of a look right here in those two slides that I've got today that show some of the debris that was formed. The nuclear meltdown they talk about was confined to the reactor vessel. It did cause a debris pile in the center of the reactor core that extended roughly a third of the reactor core. That is, a third of the fuel assembly's pipe was destroyed. Pictures on the right show pictures of this debris. The top picture shows the debris looking into the coolant spaces between the two, and the bottom picture actually shows the top of the fuel assemblies that were destroyed. This is a typical picture of control rooms in a nuclear reactor. The lower black and white picture is truly the picture of a control room and a pipe that was used at 3 Mile Island. You see up at the top of the picture the banks of lights indicating the status of the plant and the various systems. This event occurred, this accident. Basically, all the lights on that panel lit up. You see the operators actually controlling the reactivity and the position of control rods in the reactor system. Now, a critical precursor to this accident was a maintenance procedure that was performed about 2 days before the accident. Unit 2, which was the one that had the accident, the emergency feed water system was tested and evaluated, and actually they were cleaning what is called the resident. During this test, the valve that was meant to be closed and open, it remained closed. It should have been open. We'll see the controversy for this valve in the following slide. Let's look a little bit at the accident scenario. It's kind of a comedy in many ways of what happened. The picture on the right shows the reactor system, the steam generator, pressurizer, and the tank that received the water from the pressure. The first thing that happened, the valve, the condensate system failed to close. This was as they say, the beginning of the end. To reduce the amount of water being supplied to the steam generator. The steam generator is like a huge tea kettle, and it, in essence, was boiled dry. Main feed water pumps and the turbine pumps tripped within seconds after these two events. We're talking a timeline of seconds here, not minutes or hours. This is seconds. The reactor continued to put out full power. No heat absorption source. The steam generator was boiled dry. The secondary side rapidly converted to steam, and finally the emergency feed water pumps were unable to inject water into the steam generator because of the valve being closed, not open. And the power-operated relief valve and a line between the pressurizer and the quench tank, that's at item number 4 up there, opened and it failed to close, a maintenance issue. Eventually it caused the diaphragm in item 4, the pressure relief diaphragm in item 4 to rupture, and it spilled water into the basement of the containment building. Now this was basically draining the water out of the reactor system as we were trying to put the water into the reactor system. And a continuation of the scenario is that the pressure dropped in the reactor cooling system because the valve was still open and the pressurizer was not doing its job. So we were forming steam. Remember now, we've got an open system. We've got it at roughly 600 degrees. We're steaming. So water in the uppermost area of the reactor flashed into steam. The operator turned it. This was really a serious operator mistake. The operators turned off the emergency water injection pumps because they thought there was still water in the pressurizer. We were blowing water out of the pressurizer. And then the operators turned off the cooling pumps, so the water wasn't being circulated in the core anymore because they feared excessive vibrations. Basically, they feared the pumps would go into the cavitation steaming. And the steam void formed in the reactor coolant loop, plugging the flow even more to the steam generator. So this is a scenario of events that occurred during the failure of the operators and the systems at 3 Mile Island. If you want to read more, you can find NRC reports. Basically, the permitting report describes this whole process in much more detail than I've gone into this evening. Here's a picture of damaged fuel assemblies. These, again, were taken underwater. What you see is the spacer grids in the fuel assembly, which you might liken unto the separators and ink crates that we buy in the supermarket. Within the fuel assemblies, there's bellows and other rather small components that allow the released gases to be stored in the fuel assembly and not escape, or basically captured. You see that the top of the fuel assembly was destroyed, and you see the bellows sticking up out of the fuel assembly. The center picture, and I tried to indicate the area of the fuel assembly that was damaged. It's in the upper part of this fuel assembly. Finally, the picture on the right shows you the top of the fuel assemblies of the massive amount of damage that was done. And if you look really very close at these pictures, you can also see bellows, pieces of them in the fuel assemblies yet. You can also see remnants of the spacer grid. If for some of us, some of you may not remember that anything to do with 3 Mile Island. A couple of days after the accident, President Carter visited the control room of the 3 Mile Island system. And the picture on the right shows Carter in the control room. It was interesting that we were controlling this reactor, now not from 3 Mile Island, but by this period of time we had installed sufficient systems in Lynchburg, Virginia, in a war room, which I'll describe shortly, to control this reactor system from Lynchburg, Virginia. When Carter visited this control room, the focus of the employees in the control room shifted from their assigned tasks to monitor and to evaluate to the president. In Lynchburg, we were not fortunate to have the president visit us, and we found that the set points that we had identified had drifted off, and it took us about 5 hours to recover the true conditions that we wanted at this point in time for this reactor. Now, 6 years later, after the accident, roughly, the core was removed, and this rather fuzzy picture shows people standing on the top of the control rod drive structure when the core was being removed. Now, the cause of this accident has been argued over and over again in a number of investigative reports. These reports have concluded that it was a combination of personal error. Think about the valve closures that I mentioned. Think about the pumps being turned off. Think about the maintenance issue of the operating relief valve. And of the 19 pages of inquiry reports that had been published at this point in time, only 2 addressed technical issues. The rest, 17, addressed management issues and institutional issues. Tremendous amount of words were written about operator training and the maintenance of this plant, as well as operator